All right, so here is your key for 7-8 homework. So do me a favor, as you check your answers, star or circle or put a question mark over ones that you want to talk about on Thursday. So remember our rules. This is our rate, and we want to take it back up to our original function. So the first thing that we're going to do is we're going to add 1 to the exponent. So if I have a derivative that's an 8th power function, that means I started with a 9th power function. And then we're going to divide by that new exponent. If you're going to mess up, that's probably where it's going to be, because remember, if there's a coefficient there, it tags along. And then we add 1 to the exponent, and then divide by, check it out, divide by the new exponent. Told you. Because what ends up happening is when you think about taking the derivative, multiply by 9, and that becomes an 8, and then that 9 cancels out. So make sure you have that right. Oh geez, I wonder how many more I messed up. And then don't forget you're adding your C to address your constant. Okay, let's take a look at number 2. So if I want to add 1 to 5/7, 5/7 plus 1, that's where I get my 12/7 from. So my new exponent is 12/7, and I divided by my new one. Of course, dividing by fraction is multiplying by the reciprocal. So that's where my 7/12 comes from. When we look at 3, x to the 3rd, I rewrote that as x to the 6/2 power. This is x to the 1/2 power. And when I multiply my bases, I add my fractions, and that gives me 7/2 power. So for each of these, you really want to look for ways that you can simplify what it is that's happening and going on, because we don't know how to find the antiderivative or how to integrate this yet, but we do know how to simplify this fraction, and then this is something that we know how to do. So with my 7/2 plus 1, and of course that's how I end up with my 9/2 here, and then dividing by 9/2 is the same as multiplying by 2/9 plus my constant. If I have 2 separate terms, go ahead and write any negative exponents as such, and keep in mind this 2 tags along, same with this 5 tags along. Exponent to the 1 more power, divide by the new exponent. Exponent to the 1 more power gives me -3, and dividing by -3, and of course that changes my sign here. When we look at number 5, again, we want to look for ways that we can simplify. How can we turn this into a simpler thing that I do know how to integrate? This exponent applies to each of these terms. This exponential value applies to each of those terms. So x to the 5th divided by x to the 4th plus 2x squared divided by x to the 4th minus 1 divided by x to the 4th. I'm going to go ahead and subtract these exponents, and that's how I get this negative exponent here. Then, of course, we add 1, divide by the new exponent, add 1, divide by the new exponent, add 1, divide by the new exponent. Don't forget your plus c. Whether you leave it in this form or this form, it's fine. Sometimes it's easier to pull the fractions out and return negative exponents to the denominator. All right, so this is one of those rules that we wanted you to memorize. So if I were to take the derivative of 5 to the x power, I would end up with 5x times ln of 5. So of course I'm dividing by ln of 5 because that must have canceled out. because it's missing from my derivative. So that multiplying by ln 5 that canceled out was because of this. That's a hard thing to keep track of. But again, one of those things we have to memorize. I'm going to put a star next to the things we just need to kind of memorize. All right, let's check out the back. I don't know how to do this power as far as integration, but I do know how to simplify the square of a binomial. And then this is something I do know. To the 1 more power, divide by the new exponent. This 4 tags along. To the 1 more power, divide by the new exponent. This 4 tags along. To the 1 more power, divide by the exponent, c. In this next one, pi is a constant. So he's going to end up with an x. The derivative of e to the x is e to the x. And then don't forget your plus c. Or the integral of e to the x and the derivative. So this goes back and forth both ways. All right. Here's another one. This is one of the ones we memorize. Same thing here. Same thing here. 1 over x is my natural log of x plus c. Please take the time to go ahead and refer back to your notes. Don't just say, oh, I don't remember it, I don't know it. Because if you go back to your notes, the more times that you do ones like these, the more you're going to remember them. All right, let's talk about 11. So when I look at 11, I'm definitely going to do some work here. This is x to the negative first, and this is x to the negative 1/2 when I multiply my bases. I add my exponent, so I have negative 3/2 x. Negative 3/2 plus 1 is how I get negative 1/2 as my new exponent. Divide by that new exponent plus c. Anything to the negative power moves to the denominator, and 1/2 power means you're taking the square root. Dividing by a negative 1/2 is the same as multiplying by a 2. And then your c. This value here can be shared, giving me something that I do know how to integrate. Exponent 1 more, 5 tags along, divide by the new exponent. 4 tags along, 1 more, divide by the new exponent. 8 tags along, 1 more on the exponent, divide, plus c, rewrite. So this is a little foreshadowing for our next lesson. So we wind up with the sign of x. What do you think the antiderivatives are? So what I want you to think about is, so how did I get that rate? And you can say, what original function has this derivative? And by asking yourself this question, it kind of gives you what's coming next. What gives me sine as a derivative? The opposite of cosine. What gives me cosine as a derivative? Sine. And of course the plus c. And that's what's coming next. All right, tune in to the next video.